Hello, Mr. Minnick here, helping my AP students review A4, Assignment 4, out of the College Board PixLab case study. So we're working here with two-dimensional arrays in Java, and you should know that a two-dimensional array has a bunch of rows and columns, and that typically it's row major. Normally, you care more about the rows than you do the columns. So when you say that, when you give the size of an array to somebody, like the one that I'm waving my mouse over, you would say that this is 2 by 3. See, Spencer, this is 2 by 3 because it has 2 rows and it has 3 columns. So the row always comes first, and we call that row major. That might be a question on the AP exam, because though they're not allowed to ask specific questions about PixLab, that's just a concept that applies to arrays, 2D arrays, in practically every computer language you'll ever study. But there could be a rebel that chooses to do things column major and look at the columns first from that perspective, and therefore, in some unique situations, a coder might put the column first. But typically, we do things we go row by row, left to right, top down, rather than top down, left to right. Okay, so read this paragraph, understand it, apply it to anywhere else in the real world, but especially coding. Wow, I had a good question from one of those Hogue young men, and he asked, is there any reason not to use column major if you needed it? Well, yeah, if you need to do things column major, then do it. But I would say add some comments or some documentation to your code to stress to your coworkers that you're going column by column instead of row by row. Okay, so here are a bunch of methods. This is just how to work with two-dimensional arrays here in this case study. I have lecture notes for that also. And then there's a little synopsis here, a code segment of this getTotal method. And check this out, everybody that's watching this video and in this classroom right now in 2018. The outer for loop here makes use of the variable named row instead of like I or J. That's just good style to name something row. You don't have to, like R or row. But the fact is, the inner for loop, which uses column, COL, that has that empty square bracket 0 there, as opposed to the outer for loop does not before the dot length. This is what really makes the outer for loop the one that is going row major, because you're going through the length of the array. And remember, a two-dimensional array, like where I'm waving my mouse, is really a one-dimensional array of arrays. And that is crucial. I've explained that elsewhere in my videos and or class lessons. So this is crucial, especially on the AP exam or anything else you do in coding, that you know where you're putting the square brackets 0. And sometimes we put square brackets and then the variable name here, that loop index variable row, that would go there, allowing for ragged arrays where all of your rows don't necessarily have the same length. In this case, on the AP exam, they do guarantee you that it will always be a nice rectangular array. So you can just stick 0 in there because you know it's got to have at least a first row. And the length of that first row is going to be the same as the length of the row matrix square brackets 1, the length of matrix square brackets 2, and so on. Okay, we're just adding up a running total here. This is accumulation, and we're adding up all the integer values that are in this two-dimensional array called matrix, that though it's not passed as a parameter or declared locally as a variable here, matrix must be a two-dimensional array of wider scope that I have access to in this code segment. Okay, scrolling down a little bit here in this case study, and they emphasize that really a 2D array is really just a one-dimensional array of arrays. And we could use a for each loop, one of these enhanced for loops, also known as for each loops, instead of doing the row plus plus and the column plus plus here. In fact, instead of having a variable named row and a variable named column, COL, we are using this snazzy alternate version of for loops to again get a running total of a two-dimensional array, which I emphasize is an array of arrays. So very, very interesting here. One set of square brackets there, but two sets of square brackets there, but we're still working with a two-dimensional array here because of the different syntax that a for each loop uses with this colon. Okay, these exercises, I'll probably talk a little bit about them in my walkthrough of the code, how get largest works. It's basically a linear search, and how get column total works, and how get count works. Okay, then I'll be done with my walkthrough of assignment 4 once I do that. So sliding over here to my IDE JGrasp that I'm using, I have this PixLab project set up. I double-clicked in IntArrayWorker and in IntArrayWorkerTester so that I could see them both in these inner tabs. So tester is really like a client program. Tester, Professor Erickson, she just made this class as a way to have a main method that tests whether these methods work or not. There's nothing interesting here in this main method. There's no game that we're playing. It's just a bunch of call statements. And these methods right here are found in the file up above the main method. Now, the neat thing about these separate methods are that many of them use a local object variable that is created from the class IntArrayWorker, which she also includes in the source folder of this project. None of this is coming from Java itself. There's no import up here of like the color class that we're just wrapping around. This is all stuff made up so that you can learn how to work with two-dimensional arrays. So let's first take a quick walkthrough of this worker B class called IntArrayWorker, and then we'll trace IntArrayWorkerTester. So IntArrayWorker class, it's got this one property instance variable called matrix, and it's being declared private like you always should. It's a two-dimensional array of integers. It's not just a plain int that you can set equal to 0. And anyway, this is not where you should set things equal to 0 anyway. But if it's something that's an object, which a two-dimensional array is technically an object, it's not. There is no class called like matrix that you would do like that. But it is an object the way Java treats it. So you can set things equal to null. And as far as I know, if you don't explicitly set it equal to null, if you just do that, it's still set equal to memory address 0 on your computer, which is what null is. So the equals null is just there to be nice and obvious. There's no constructor in this class. So by default, Java, if there is no other constructor if there are no constructors in a class, it automatically provides a behind-the-scenes default constructor. So you can assume that there is a constructor that would do something like this behind the scenes. It would probably have a double-nested for loop, and I'm just really quickly showing you. I'm going to pause my video. Okay, coming back online from a pause on my video. So this would be a real quick, cheesy default constructor that sets all of the elements of this two-dimensional array matrix to the value 0. Real quickly, I think that works. Yeah, I think that works. Anyway, if you don't explicitly type that out, Java in this case would provide a default constructor that sets all those elements equal to the integer value 0 for you. And Barb Erickson knew that when she created this class. Okay, we have a set matrix method that takes a whole matrix that was already preloaded with numbers and plugs it in there, a little modifier method named set matrix. That's pretty cool. That's like a 9 for the price of 1 assignment statement. If this matrix is 3 by 3, 9 numbers, 3 by 3, 3 times 3 is 9, are all being plugged into the corresponding elements of matrix in one shot. Pretty cool. Okay, this is what you really have to know for the AP exam and pretty much anywhere in life that you would become involve yourself with coding. So we have a double nested for loop that uses the typical row, major, column, minor way of filling up, adding up a running total. And you all know that that total, that could just be total plus equals. And that's just the way it works. We have a local variable set equal to 0. It gets out total. Then we are sure to return it because we're returning an int. Moving on, she gives us a for each loop way. I explained this earlier in the video. You saw it in the case study. I'm going to add better style to her code because I like blank lines around things. And you know what? I like that plus equals because it's just cool looking. And she has a method called fill count. Ooh, look at this. It fills an array. Props to Professor Erickson for having a cool method here that we just analyzed it. I didn't really understand that at first. But if you had a tic-tac-toe board here, a 3x3 tic-tac-toe board, count, because it starts at 1, it ends up putting a 1, 2, 3 across the top, 4, 5, 6, 7, 8, 9. So if you did this, you changed, well, this is row major. I don't want to do that because I don't want to do something for you that you're supposed to be doing in your exercises. Real quick walkthrough of this method, print, this prints out the matrix in a human-friendly Excel spreadsheet kind of way. Notice the placement of this system out print. Eyeballs up here, students. I have one more minute in this video. That system out print is what causes each row to actually move down to a new line. This system out print is just there to basically pad the next thing that this program prints out down below. That's really unnecessary, but this is crucial. I'm going to add the little comment, moving to the next line of output, because that's kind of handy. And I like blank lines around my stuff, you know, so I'm just doing that. Notice again, she has the square brackets 0 on the inner for loop and no square brackets 0 here, so she is going row major. There's something called a transpose of a matrix if you study it in linear algebra or higher up in math, where you want to take a tic-tac-toe board and kind of flip it 90 degrees. And that's something that you might study in business math later on in your life. So in that case, you would want the square brackets 0 here and the no square brackets 0 here. And then it would go column major, row minor. Okay, fill pattern. Well, this is kind of cool. I'm going to pause the video and ask a student to explain this. Okay, I had some bright students tell me that, oh, why did she put that down there? That this double nested for loop arrangement with an embedded if, else, if, else, if. Imagine this, everybody that's watching the video. Imagine a tic-tac-toe board here, and down the main diagonal that's kind of from left to right, there are 2s. And above that diagonal, where row is less than column, in the upper right corner of that sort of tic-tac-toe board, there are 1s. In the bottom left corner of that tic-tac-toe board, there are 3s. Now that's pretty boring with just the numbers 1, 2, and 3s in a tic-tac-toe board. Now imagine a picture of something interesting to you, something that you have on Instagram. Imagine a two-dimensional array of pixels. And down the main diagonal, I don't know, it's like all white pixels, like the Ghostbuster logo. And then in the background, in the upper right area, all the pixels are like gray. And in the bottom left, all the pixels have some blue tone. So the RGB, they took the B and they upped it to 255, and maybe the R was subtracted. So you gave it a tint, but it still looks like whatever the picture was in the real world. That's the kind of Photoshop type effect or Instagram effect or Snapchat filter or whatever they do in that world. That's what we do. We do this kind of algorithm to pixels. Okay, that's installment 1 of our walkthrough of IntArrayWorker. Perhaps in the next video, I will come over here to IntArrayWorker Tester and test these methods, which kind of make use of the methods that were over there explained in this previous video. Have a great day.